we got? What would be the opposite of 8?
-8.
Yeah, there we go. -8. If I have a -10, what is its opposite?
10.
10. What if I have a y? Ooh, so close. -y.
How's X? X is
All right. If I have 3x, what's its opposite?
-3x.
-3x. And then a -34a.
34.
34a. Okay, so this is very important for what we're going to do. We're going to learn the second algebraic method, and you have to understand what is an opposite first, and then how to create them. So how do we know if two terms are opposite? How can we summarize what opposites are? Okay, so I can say positive versus negative. You can flip sign. Okay. What's another way of describing if it's an opposite? Here's your clue. Looking at 1 and 2, if I were to add them together, what happens? They would cancel out. They would equal 0. Okay, so they would cancel. They would cancel each other out. Does that kind of make sense? This is very important. That one little skill, identifying opposites, is necessary to use the second algebraic method, which is elimination. That's what we're going to do today. So I highlighted the key information. So when using the method of elimination, it says we add two equations and a system together. Our goal is to eliminate one of the variables. So they have to cancel each other out. That's why you need opposites. Okay? Then we're able to solve each variable separately. So our goal is to eliminate, okay? To use elimination. So if we look here, a couple things that I'm going to do to help you make sure you're using elimination correctly. The first thing is your terms, your variables have to be lined up. For example, if you look the first term here, my x's are lined up. They're stacked underneath each other. Do you see that? Okay, so our x's are lined up. The y's are lined up. And the constants are lined up. You can only use elimination in standard form, okay, using standard form, which means our variables have to be lined up, okay? And then we are going to look for the opposite terms. Do we see which variables are opposites? Okay, I'm just going to draw an arrow. This is our opposite terms. Just make a note of that. Okay, because those are our opposites, if we add them, they would cancel and become 0. Does that make sense? That one little skill, that one little observation, okay? All right, so when they cancel, we're just going to add everything else up. X plus the 5x now gives me a total of 6 x's. Okay, -19 plus 1? -18. And now we're just going to solve for x. Yep, divide by 6. Cancel out that coefficient. X equals -3. Okay, now, because we're solving a system, your solution is always still going to have to be an order pair, an x and a y. Okay, unless we have a false statement. If it's a false statement, who remembers what that becomes? No solution. Very good. If you have a true statement, then what does that become? Infinite solutions. Okay, so what we're going to do, because we now have this answer, I need to put it right here. I'm just going to put a little star. We're going to plug or substitute into plug back into, plug back into one of the equations. You can pick which ones you want to use when you plug it back in, okay? So when you plug it back, it's either the top one or the bottom one. Which one do you think is probably easier to plug it back into for? Yeah, the top one. I would plug it back in to the top. So that means when I'm plugging back in, I'm using my parentheses. So I have basically for x, since we have x minus 2y equals negative 19, that really becomes negative 3 for the x minus 2y equals negative 19. So I need to make some room. So I'm solving for y here. So I have to isolate that term. So that means to isolate, we're not going to add 3 on both sides, to give me a negative 2y equals negative 16. Divide that by a negative 2. Y equals 8. So my solution, or the answer, is the order pair negative 3, 8. Okay. So the key for today's use of elimination, we're gonna use the first method, or first part is just looking for opposites and figuring out which term can be canceled. Okay. All right. So now let's look at the next one. Which term is an opposite? Which variable could you cancel? Yeah, very good. The x. One's positive, one's negative. Add them, cancel out the x. That's gone. Add everything else. 2y plus a y now gives me a total of 3 y's. 5 plus 7 gives me a total of 12. So my y equals 4. Okay, we're boxed at. Are we done? No, we need to plug it back in. Which one do you want to plug it back into? We're going to go to the second one. Okay. Well, guys, just think about that. Negative x plus y equals 7. So if you have a negative x plus 4, because that's our y, equals 7, you can do that mentally. You can think, what number can I basically add to the 4 that I would have a positive 7 as an answer? Okay, minus 4, right? Minus 4, right? So we get negative x equals 3, right? So what is x? Yeah, it's a negative 3, because you're going to have to divide this by a negative 1. So x equals negative 3. So our answer is negative 3, 4. Okay. All right, flip it over or open it up. Okay, so here are our steps when using elimination. Step 1 says write this system in standard form, which is ax plus by equals c, so that the like terms are lined up. It says line the variable terms x and y on the left side. So just remember your terms x and y, left side of the equal sign, constants on the right side. Variables on the left, constants, your numbers, on the right side of the equal sign. So make sure it's lined up. That's first. Step 2 is to find or create a pair of opposite variables to eliminate. Find or create a pair of opposite. So they gave you an example. So it says like 7x and a negative 7x. Now, I'm going to put a little star here. This is going to be day 2. This is going to be tomorrow. We're going to focus on what to do to create. It says here, to create a pair of opposite variables, you will have to multiply one or both equations to create an LCM. Your LCM, because you're going to multiply here, your LCM is your least common multiple. I ran out of room. Least common multiple. It's been a while since we talked about those, but we're going to use that. All right, then we're just going to add the equations and solve for the remaining variable. And then just the last step, substitute your answer in one of the original equations and solve for the other variable. So make sure if you get a solution for a variable, you sub back in to get the second one. Okay, so key information, 4 steps. You need to memorize these steps. Make sure you know them by heart. We're going to just memorize and apply. So we're going to practice using these steps to make sure you can master the first type, which is just identifying opposites and adding, or creating an opposite and add. Okay, so we're going to solve the system by method of elimination. We got y plus 3x equals negative 2, and 2y minus 3x equals 14. So do we see a pair of opposites? Which, yeah, positive 3x and negative 3x. So we add here, we can cancel these x terms, right? So add the remaining. This would be 3y equals 12 again. So that means our y equals 4. Then once you're done, you need to plug it back in. Which equation do you want to plug it back into? All right, we're going to plug back into, so plug back in. Back in. So y plus 3x equals negative 2. We're going to substitute the y with 4. And then now we have our plus 3x equals plus 3x, equals negative 2. Well, once you subtract the 4 on both sides to cancel out and get the x term isolated, we have 3x equals negative 6, so x equals negative 2. So our answer, or our solution, so the solution is the point negative 2 comma 4. Okay, so I'm going to put a little star here. Okay, this example. Oops. Let me move this up. All right, I want you to look at this next set. Do we have any opposite terms?
No.
So now we're going to have to create an opposite. Oh, this. Make sure it's negative. Yeah, it was supposed to just be equal to 8. Okay. All right, so to be an opposite, you want to have the same coefficient, number in front, and same letter, okay? But right now, they're not opposite. So which term would be the easiest to create an opposite to? The y. Why is it the y the easier one? They have the same number. They have the same coefficient, okay? So if you see the same coefficient, all we have to do is multiply by negative 1 to create an opposite.
Or you could just subtract.
Or we could just subtract. You're right. So which term do you want? Which equation do you want to make an opposite? The top or the bottom?
Bottom.
Okay, so put parentheses around the bottom. Put the negative 1 outside the parentheses. We are now going to distribute this negative 1 to each term. Okay, so I'm going to rewrite what it becomes. It becomes, if I do a negative 1 times a negative 2x, that now becomes a positive 2x. Negative 1 times 4y now becomes a negative 4y equals, and this now becomes a negative 8. Everything else on the top remains. So we have 3x plus 4y equals 18. So now we can add them, and now our y's will cancel. All right. So when we add, we get 5x here equals 10. So x equals 2. Then we just need to plug it back in. All right, when we plug it back in, go back to your original. Do you want to do the top or the bottom equation?
Top.
All right, let's do the top. So we're doing 3x plus 4y equals 18. So this is going to be 3 parentheses 2 plus my 4y equals 18, which is really just 6 plus 4y equals 18. Subtract the 6. So we get 4y equals 12. So y equals 3. So our solution, is the order pair 2, 3. Are we okay on that? So if it's not an opposite, focus on same coefficient, same number in front, and multiply by -1. All right, so let's look at the next one. We do not have an opposite, but if I multiply, I could create an opposite. Which term, the x or the y, could we create an opposite for? The x, because the x, the 3x is positive, the minus x is negative, right? So what would you need to multiply this bottom equation by to make it an opposite? So close. What did y'all say? Oh, so you do have, oh, okay, so let me take this off. You have 3x negative 3x plus 2y
Plus 3y.
plus 3y equals 3. Okay, sorry. All right, so the x's are opposite. Everyone see we can cancel out the x's. That equals y equals 6. All right, so there's our y. Let me look at my copies. All right, so there's our y's, and all we need to do is plug it back in to get the 6. Okay, so this was a different one too. All right, so when we plug back in, you're gonna do the top or bottom? All right, bottom. So negative 3x plus 3 parentheses 6 equals 3. So that is really a negative 3x plus 18 equals 3. Subtract your 18. That leaves you with a negative 3x negative 15 equals negative 15. So x equals positive 5. So our solution is 5, 6. Okay. Okay, so this one's different too. Or y'all's, my problem is different than y'all's. Okay, so on here we have 2x minus y equals negative 6 and 2x plus 3y equals 14. I wonder if everything else is the same. I gotta double check it. All right, so we need to create opposites because we don't have a flip of a sign but the same coefficient. So on this one, what we're gonna need to do to create an opposite? Yeah. Okay, which one do you want to multiply by -1? Okay, bottom by -1. Okay, so when you do that, make sure you do that to each term. Okay, so this makes this negative 2x minus 3y equals negative 14. And now when I add, the x's will cancel. Now this becomes a negative y plus a negative 3y. So the answer here is negative 4y. Negative 6 plus a negative 14 is a negative 20. So y equals positive 5. Remember, you're adding, so you have to, if they're the same sign, you just add them together and keep the sign. All right, we need to plug this back in. Which one do you want to plug it back into? The first one. So we're going back to the top one right here. So this is 2x minus 5 equals negative 6. So when you add 5 on both sides, 2x equals negative 1. And then when we divide by 2, what's our answer going to be here? Negative 1/2. You can have fraction answers as a solution. Sorry. So the solution is negative 1/2, comma 5. Okay, so on our practice guys here. Oh shoot. That wasn't supposed to be there. Sorry. Yep. All right, we're gonna put an E because I want you to pick the best method. I actually need to fix this whole thing because it's not right. All right, practice with systems. Use either substitution. So if you use substitution, put an S, or elimination, put an E for what you think is the best method. You can only use substitution when? When can you use substitution?
When there's opposite.
No, that's elimination. Substitution is when you have isolated variables. That means when you have y equals or x equals. Elimination is when you have opposites. Okay? So that's the key. Check to see if you have isolated versus opposite terms. All right, number 1, which is probably the best method.
Yeah.
Number 1?
Oh, no. Elimination.
Yeah, elimination. I'm gonna put an E. Okay, I'm just gonna put an E for elimination. All right, because they're opposite right here, you can add and cancel out the y's. All right. What did I do with my thing? All right, now number 2, what do you think is the best method? Yeah, number 2 is substitution because it has x equals. So I'm gonna circle what it equals, that 5y, and we're gonna substitute it in for the x. So use parentheses when you do substitution, and that would be 3 parentheses 5y, close the parentheses, minus 4y equals 11. And now you can solve it. Oh, this is very fast. Okay. Do we understand what we're kind of doing here? Picking the right method and then solving it using that method. Like number 3, which method do you think is the best? Yeah, 3 is an E again, elimination. See how if you add, your x terms will cancel because they're opposite. What about 4? 4 is a substitution because it's y equals x plus 3. So then you have to plug it in for the y. 3x plus parentheses x plus 3 equals 11. Are we okay on that? All right, so I'm putting time on the board. I'm stamping this. I'm checking these, 6 problems in class. And then I'm going to give you your homework.